So I'm going to do a quick summary of all the goody two-shoes stuff I do. So there's Rails Bridge. Like Josh said, this holds workshops around the world. They're free to everyone. We're for women and marginalized groups to learn Ruby and Rails. If you want to have one near you, talk to me. Bridge Foundry is a way that you can get your technology in the hands of marginalized groups too. So if you want to do that, talk to me about that. And tomorrow night, GitHub is holding a patchwork workshop, which is a free workshop for anyone who wants an intro to Git and GitHub. So there's a link to all of these things in a handy bit.ly bundle I made for this talk. So if you want to RSVP to the patchwork, if you want to do Rails Bridge or Bridge Foundry stuff, you can check it out there. This is bit.ly/service-oriented-disasters, all one word. It also contains links that are actually relevant to my talk. That was a joke. It's fine. Thanks, y'all. Thanks. So before jumping into service-oriented architecture, I want to say a few words about code complexity. So code complexity is a problem that everyone that's running a Rails app is going to run into eventually if you don't have it already. It's easy to get a Rails app started, but as that application grows, parts of the code become entangled with other parts. So as applications mature, we need to be thinking about this more and more, and we need to start addressing every feature as a way that we can extend in the future. Secondly, high-level architecture decisions. Is architecture the bad word that everyone's saying? I'm going to say that I wasn't sure if it was agile or architecture. Someone's afraid of some word, and I don't know what it is. So high-level architecture decisions, like whether or not to extract code into services or keep it all into one application, can have a huge impact on code complexity and where that complexity lives. So we should absolutely be thinking about that as we decide our architecture. We should aim for an architecture that's going to reduce the overall complexity. And when we're thinking about those things, we are really lucky that we live in the age of Sandy Metz. Sandy Metz has extensively addressed how to deal with code complexity, and I think she's done it really well. So I'm now going to try to summarize all of her points, like a lifetime of work in one slide. It's going to be fine. The gold standard, according to Sandy Metz, to remove complexity is that you should refactor to have each class representing a single responsibility. That class could still have complexity inside of it, but the class itself should conceptually be simple. You know that it's doing one thing. And we should refactor the methods in those classes so that they become shorter, readable, better named, and that would generally make them easier to change and reuse in the future. But those sorts of refactors can be a huge amount of effort, and you don't necessarily have a lot to show for it when you're done. You haven't shipped a new feature. So because of that, it's necessary to compromise. To concentrate your efforts on reducing complexity in the most important code paths, you want to find places that are tightly coupled, where your application, where you pass through that code often. So like if you have complexity in a place that you never use, you don't need to worry about it that much. And that's the last point. So stable code paths that aren't changing or they're at the end of the line, are places that the complexity won't get in your way. Sandy Metz, everyone. One slide. So I linked to Sandy Metz and her blog, her book and her blog in the bit.ly bundle. So one thing that she hasn't jumped into is all of the conversations around service-oriented architecture. I really loved Sabrina's talk earlier about how to rewrite a complex Rails app into services. That was great. I'm going to give kind of a contrasting perspective of how I've messed it up. We'll complement each other. So I think it's useful to bring these two conversations about service-oriented architecture and code complexity together into one conversation. Because I think service-oriented architecture has been misunderstood by a lot of people as an approach to managing complexity, and I don't think that's actually what it is. So if service-oriented architecture is new, which at this point in the conference, I'm sure it's not, but it is SOA for short. It's a style of managing software by building small services that each represent a distinct function. And the goal behind SOA is that it's easier to maintain, it's more sustainable to scale than supposedly a large monolithic application. So there are a lot of talks and blog posts, there are some books, and they're all focused on the benefits of building out a service-oriented architecture. Lauren, yesterday, gave a really great talk about how to extract a service from an existing application. Sabrina did the same thing today. I'd like to see more blog posts and talks and things like that that investigate the ultimate success or failure of these projects. I think we're in the beginning days, so maybe that's not available yet. I'm going to try to start doing that in this talk, and I look forward to more evidence as it comes in. I'd like to see what the success or failure ultimately is of breaking these large applications into smaller services, because I think SOA it works in some specific cases, but maybe we shouldn't be trying to replace all of our large Rails apps with services. There are some real downsides. It's possible to end up with services that are difficult to test, that are confusing to debug, that are 5 times the work to deploy. And to echo a point that was made yesterday by Coraline, a bad SOA implementation can create an ecosystem of services that reflect your bad app with the added complexity of network failures. It's not necessarily one. What happened? Is that okay? Okay. Okay, so I brought, oh wait, that's cute, I should let you read it. This is me in real life. So I brought 3 case studies today of failed SOA implementations from my own experience. And I see these as guiding me to see now what the right and wrong cases are for a service-oriented architecture. And all the stories are true, but I've changed the domain model to protect the guilty. Specifically, these code samples are now the adventures of hatsforSpaceDogs.com. I grabbed the domains, so you can't have it, but there's something there. So the first case study, extracting tangled code. To set the stage a little bit, the team at hatsforSpaceDogs.com got a request for an old neglected feature on the site that would let space dogs vote on hats, and then we'd sell the winning hats on the site. Thanks for just going with this. So most of the app was reasonably well factored, but we rarely touched this part of the app. It wasn't core to our functionality, and so it became much more tangled than the rest of the code. The client-side code was the absolute worst. The entire feature was one long function where it mixed behavior with presentation and weird bug fixes over and over and over. It's a really simple feature, and so it's amazing that it became dauntingly complex. I think it's because it just had no structure. The server-side code for the feature suffered a very different problem. The hats that you could vote on were the same classes as the hats you could actually buy, even though the behavior of the two were entirely different. Cool. To make it more confusing, if the hat ended up winning the contest and we were going to sell it on the site, we created a second hat record, and they had an association with each other. So is anyone angry yet? You might feel angry. So that's a good response. So it's a confusing data model that we're working with. And if we had been trying to manage our complexity here, we would have followed the advice of Sandy Metz, and we would have refactored this into 2 separate classes that describe these 2 separate types of behavior that's right now wrapped up into the same class. We would have stuck to the single responsibility principle. But we didn't. So as we looked at updating this feature, we wanted to solve some of the problems with our existing code. In Rails, that hat model was violating the single responsibility principle. It contained behavior for what I'm going to start calling buyable hats and votable hats, just to keep it straight. Secondly, the front-end code was so confusing that it seemed nearly impossible to refactor. So that's all to say we had unmanaged complexity. And we thought we could see some clear lines around what could potentially be extracted. We wanted to have an app made up of votable hats and votes. And we knew some things about SOA. We knew that SOA meant creating small, well-defined, easy-to-maintain services. That sounded great. At least it was better than what we were currently doing. So we started rewriting those features in new application. We ran Rails new, and we defined the data model we had always wanted. And then we started planning how to import the old votable hats records into our new, which were really hat records, into our new votable hats application. This was glorious. It was fast moving, and we were doing the thing that we thought, like, God wanted us to do. Then we started working on a migration script that imported votable hats and its association into our new application. And we had to, like, fudge it with it a little bit to make it fit our new data model. That's where things went downhill really fast. So just to give you a sense of the complexity that we were encountering, did the votable hat win the contest? If so, is that hat available for purchase, and should we link to that? If it's available for purchase but slow in stock, do we need to put this little banner on it? Or if it won the contest but it's not yet available, then the app needs to give them a link to pre-order instead of to purchase. So all these things we start hitting all these little questions. So we realized that the votable hats had more dependencies on the hat model and weird things in the hat model than we realized. But we didn't give up. So just to kind of diagram it out, we started with our main application and the new votable hats app, and they each had their own database. Seems really sane. We did one bad thing. We connected to the old database so we could get some information about the existing hats. Should have been a warning sign. Then we realized the main app needed some attributes about votable hats, and we couldn't wait for our API to be done. So we connected to the votable apps database. It was fine. We should pause here to note that this is the diagram of doom. If you find yourself drawing this diagram, you should stop. You should go get coffee. You should maybe go look for a new job. You should stop. What it tells you, this diagram tells you that you've drawn the lines around your new service incorrectly. We were not actually extracting an independent service here. So at this point, we would be on firm ground if we called this a disaster. But let's keep going, because we kept going. So we realized there's so much complexity in the hat model and its associations that the quickest thing to do would be to reuse all of that in the new application. So we packaged up all of our models into a gem, which we started sharing with our new app. Cool. So just to say a few words about this awesome diagram of doom. Rather than separate out the votable hat behavior from the buyable hat behavior, we created an ecosystem of services that mirrored our unmanaged complexity of our original code base. Not a win. Let's reflect. What can we learn here? So first and foremost, we did not draw the correct lines around our new service. We drew it around a customer-facing feature rather than a logical unit in our app. And there were a lot of things going on in that feature. We also drew the lines without understanding the code, almost as a way to avoid having to understand the code. And we did that because we thought SOA was going to be a way to manage our complexity, but that turns out to not be the case. The hat model was a problem for us, and instead of refactoring it to understand the dependencies so that we could then extract some unit that we understood, we just tried to start extracting before we understood. But guess what? There's a happy ending here. We realized this was a terrible idea. We backed it out, and it never went into production. Ta-da! So this sort of thing happens at GitHub, too. GitHub.com is a giant monolithic application written in Rails. There are corners of it that are neglected and poorly tested, and that makes refactoring risky. But those are also the places that are essential to refactor. So to help with those refactors, GitHub maintains an open source project called Scientist. Here it is, but I also linked to it in the bit.ly bundle, so you don't have to write it down. Scientist works by letting you define an alternate code path, and then in production, it will run the old code path and the new code path, and then it reports back if they agree or disagree. So the user will still get the old code path, the result of the old code path. So it's a way to dark ship your rewrite and then find out how it's doing with real users and all of the mini situations they get into. So sometimes you'll uncover bugs in the old code. Sometimes that will lead you to weird corner cases you hadn't thought of in your new code. And Jesse Toth, who recently wrote a lot of the permissions code in GitHub, gave a talk a few months ago about how she used Scientist to rewrite all of the permissions code. that was gnarly, not fully tested, poorly understood code. And when she rewrote it, when that eventually shipped, it was rewritten to have tests, to be easily understood, to be extensible. It was a really impressive rewrite, and it didn't take nearly as long as you would guess. Shout out. So, on to the next case study. Back at hatsforSpaceDogs.com, we set out to build an identity service, a service that would manage authentication and authorization for our applications. We had complexity in two models, our hat model and our space dog model, our version of a user model. And we thought an identity service would help us manage complexity by isolating the complexity of the space dog model, not a user dog, from that part of application. So setting out to build this identity service, we thought we'd try to solve a few problems. So we wanted to isolate complexity. And this was a small improvement because we defined our first service for the votable hats based on a customer-facing feature. And now we were defining it around one of our Rails models. So we learned some things. Secondly, we knew the code in there was confusing, complex, and we thought one thing that would help us with this was to have team ownership over this model. So we thought extracting it into a separate repository would help with that. So we knew that we didn't want to end up with closely coupled services like votable hats, but we still saw service-oriented architecture as a way to get small, easily maintained services. And this time we hoped it would help define team ownership. That's not what happened. So first, we didn't give the identity service a database of its own. This was our grand idea. When a request would come into the main app, it would hit the API for the identity service, which would query the main database, and then it would return a response. It was a little circuitous, but it wasn't terrible. Then we built a mobile app. You might think, this would be the same thing to think, that the mobile app would hit the identity service, which would query the database, and eventually get back a response. But we didn't sit down and understand all the places that the space dog model was doing things all over the main application. So we were never actually able to fully extract the identity service. So every time the identity service, it needs to call back to the main application. And so two things were hitting the database every time before you would get a response. This is a disaster. This is actually a much more dangerous disaster, in my opinion, than the votable hat app, and not just because it went to production. It also brought with it a lot more operational complexity. The identity service wasn't capable of functioning without the main application. And the main application wasn't capable of functioning without the identity service. That meant that both of them need to be up all the time. If either of them went down, you couldn't shop for your hats as a space dog. And so we had like shifted workload onto the operations team without a clear win at all. This became the worst of all worlds. We had added a single point of failure, one that wasn't widely understood, and we didn't actually relieve the main app of any load. So this is where I'd like to talk about SOA and scaling. We naively thought that anything that reduced load on the main application would improve overall scalability. Just to like throw some numbers that are entirely made up, like however many people are at Rails Girls and Rails Bridge, that was all made up, by the way. We needed 2,000 servers for the main application. If we added 100 servers to handle just authentication, we thought that would be an improvement. But the identity service had the same uptime requirements as the main application because users need to be able to sign in. And here we can use a little queuing theory to see how that would actually hurt scalability. So if we just entirely ignore the extra network calls, if we have 2,000 servers serving up requests for the main application, they're still going to have to go hit this. They're still going to have to get in line again to authenticate, right? So they have to have a second step, and there are only 100 servers for those. So it's creating an artificial bottleneck that we didn't need to use there. What we could do instead is, if most requests could be served from one large pool of servers, then a certain set of requests will get there faster. Yeah, here's the version where you don't have the artificial bottleneck. So SOA is a bad strategy in these cases because maintaining the speed of the user experience would require that we scaled up both of those, so neither one of them would become a bottleneck. This calculation changes, though, if you have different uptime requirements. And I know this is kind of a weird thing to talk about at a Ruby conference, so I included some queuing theory links in the bit.ly bundle. Okay, and the other main project that the other main goal that we had with this project was to define team responsibilities. And there's an alternative that I can pull from GitHub. We have a very unglorious and super simple way to deal with this on our main application. We have a YAML file. And for every single file in the application, there's a team that's assigned to take care of that file. It saves us a lot of work. Everyone knows who is responsible for a file, and if I want to change something in that file that's not my file to change, I need to work with them. I need to talk to them. So sometimes simple is okay. So this brings me to my last case study. This is one that I don't think had to be a disaster the way the other two were just doomed, but the implementation made it one. So we had a monolithic Rails application, and the really great thing about monoliths is you only need one set of assets. But soon we